Okay, so yesterday we discussed what net force was. Net force is the total force being applied onto an object. So in this diagram, we have four forces. We have an upward force, a downward force, and we have two forces pulling to the left and to the right. So what we do when we calculate net force is if the arrows are in the same direction, we add them together. If they are in opposite directions, we subtract. So looking at this diagram, the first thing I notice is I have 1 Newton pulling to the left and 1 Newton pulling to the right. So there is an equal force in opposite directions. They are both pulling away from each other with 1 Newton. So they cancel each other out. 1 minus 1 is 0. So this force and this force cancel each other out. So now all I need to focus on is this upward force and the downward force. Now they are opposite. They are pointing in opposite directions. So I subtract. 5 minus 2 is 3 newtons. Okay? Now, it's very important to remember that there is no such thing as a negative force. Like when we subtract, you should never have a negative number. The larger force will always be on top. Okay? The larger force will always be on the top when you subtract. So 5 minus 3. 5 minus 2 gives you a total force of 3 newtons. The next step is to determine what direction the object will move. Okay, so when we look at this object, we have a greater force pulling up. 5 newtons is the strongest force being applied to this ball. So what direction do you think the ball is going to move in? Good, the backpack is going to move up because the upward force is the greatest force being applied. I got 3 because I subtracted 5 and 2. When your forces are in opposite directions, you subtract. So because this force going to the left and this force going to the right are equal and opposite, they cancel each other out. 1 minus 1 is 0. And then these, the upward force and the downward force, are also opposite, so I subtract. 5 minus 2 is 3. Okay, and we know the object will move up because that's where the direction the greater force is being applied. Okay, so let's do the same thing with this boat. We have an upward force of 1,000 newtons, a force being pulled to the right of 80, a force pulling down of 1,200 newtons, and a force to the left of 80. So the first thing I notice is that the force pulling to the left and the force pulling to the right are equal, and they're pulling in opposite directions. So they cancel each other out. 80 minus 80 is 0. But my force pulling up and my force pulling down, they are not equal, but they are opposite, so I subtract. When your arrows point in opposite directions, you are going to subtract. So 1,200, because that's the bigger number, minus 1,000, okay? 1,200 minus 1,000 is 200. So my net force is 200 newtons. Okay, and the boat is going to move in which direction? All right, good. Everybody is answering it right. The boat is going to move down because there is a greater force pulling the boat down. This poor boat is practically sinking. Okay? All right, now look, we only have 2 forces being applied on this balloon. We have a force to the left of 14 newtons, and we have a force to the right of 5 newtons. So these arrows are in opposite directions. One's to the left and one is to the right. So we need to subtract. 14 newtons minus 5 newtons. Okay? 14 minus 5. That gives me a net force of 9 newtons. Keep in mind, guys, I am always putting the larger number on top. 9 newtons is my net force. What direction will the balloon move in? Okay, good. It's going to move to the left because there's a greater force to the left. All right. Let's look at this next example. Okay, so we have a car. Now, notice this car is moving. The car is moving. That's what these little lines mean. But we have 4 different forces that are acting on the car. We have an upward force of 100 newtons, a downward force of 100 newtons, force to the left of 600, and a force to the right of 500 newtons. So again, the first thing I notice is 100 newtons up and 100 newtons down. They're in opposite directions, and they are equal, so they are balanced. They cancel each other out. But my force to the left is 600 newtons, and my force to the right is 500 newtons. So I need to subtract those. 600 newtons minus 500 newtons gives me a net force of 100 newtons. What direction is the car moving in? Is it moving to the left, to the right? Good. It's moving to the left. Awesome. Okay, we got 2 more examples. All right, so we have a box being pushed to the right, and we have a person pulling the box to the right. So there's only 2 forces, but what I notice is that my arrows are both pointing to the right. And a strategy that I like to do is I like to write the letter of the direction. This is pointing to the right, and this is pointing to the right. So my forces are the same, which indicates to me that I need to add all the forces being applied in the same direction. So I need to add. Okay, so 18 plus 11. When your forces are in the same direction, you add. So my net force is 29 newtons. Okay, I have 18 pushing and 11 pulling. So when you add them together, you have 29 newtons. Now, what direction is this box going to move in? If you think about all the forces going to the right, they're pushing to the right and he's pulling to the right, all of the force. So this box is going to move to the right. Okay, good. All right, our last example. We have an upward force of 200 newtons, and we have 2 downward forces of 100 newtons. Gravity is pulling down on both sides of this, I forgot what it's called, this thing, at 100 newtons on each side. So what's the total force that's being applied? Well, our forces are in opposite directions. We have 2 downward forces, and we have one upward force. So we need to subtract 200 minus the total force pulling down. So the total force pulling down is also 200. So we have a total force of 200 pulling up, and we have a total force of 200 pulling down. Your total force is 200 minus 200. So my net force is 0. 200 minus 200. Now, when your net force is 0, that means that this object's motion will not change. This object's motion is balanced. The forces are balanced, therefore there is no change in motion. So if this object is stationary, it's staying stationary. He's not using enough force to pull it up, okay? So the direction of the motion is the forces are balanced, so there is no change in motion. And what that means is when your forces are balanced, when your net force is 0, whatever is in motion is going to stay in motion at a constant speed. And if it is not in motion, if it is at rest, it is going to stay at rest. That is Newton's first law of motion. Okay? So when your net force is 0, then that means it is balanced and there is no change in motion.